Okay, Ramai, you already know about this periodic table, and you know about the periodic table which we are going to learn. Learned, we already learned. It is this periodic table with 20 elements in it. So, in this periodic table, now we are going to learn about metals in this one and some examples for metalloids and non-metals. So, uh, as your knowledge, you know these are okay. We should remove hydrogen. As your knowledge, you know these are what metals, and let's use another color for metalloid. So this two is the metalloid, and we have non-metals. These are non-metals including this hydrogen. Okay, this is something which you already know. So we are going to learn about some metals in order to know their characteristic and about some non-metals and metalloids. So the sodium and magnesium are the elements that we are going to learn. Sodium and magnesium. And what are the metalloids? There's only two metalloids exist. We are going to learn about sodium and magnesium, and boron and silicon. They are already present in here. So we are going to learn about them as metalloid, and finally carbon, nitrogen, and sulfur as example for non-metals. Carbon, okay, I can't highlight them here due to something happened in this one, so I'm going to draw. So we are going to learn about carbon, nitrogen, and sulfur as non-metals, and sodium and magnesium as metals, and boron and silicon, about boron and silicon as metalloids. Okay, let's go. So here we have metals. Of the elements identified so far, more than 80 are metals. They refer to this large table. Okay, see, metals, these are all are metals except this non-metal. See, and hydrogen is also non-metal. All are metals. See, so of the elements identified so far, more than 80 are metals. In nature, these exist as native metals as well as compounds of metals. Metals such as silver and gold are found as native metals in nature, whereas many metals as iron, aluminium, magnesium, and sodium exist as their compounds. There's a reason for this one, because silver and gold, they have a low reactivity. When we discuss about activity series, their reaction, they have comparatively low reactivity than what? Than these iron, aluminium, magnesium, and sodium. So they have less reactivity. And when it comes to physical properties of metals, here we are going to discuss basically that physical methods of common metals. Given below are some properties of metals. Have a metallic luster, sonorous. You have already know these things because we learned them in previous grades. Metallic luster, sonorous. It's the ringing sound when struck. Exists in solid state at room temperature. There's an exception, it's mercury. Even though it's a metal, it's a liquid. That's an exception. Malleable, what is that? Can be hammered into sheets, and ductile, can be drawn into wires. Good conductors of what? Both heat and electricity. Generally have a high density. So there is 6 main characteristics of physical characteristic of metals. Now we are going to learn about chemical characteristics of metals. Metals form positive ions or cations by losing electrons. This is a chemical uh, characteristic. You can observe it because those metals, here the metals are laid in the first two groups, no? And aluminium it's in the first third group. So all the metals are laid in the first three groups, so it is easy for them to remove an electron and obtain this noble gas electronic configuration. See, lithium, it won't get electrons and reach here. Easily it remove its electron and reach helium. तर lithium වගේ කෙනෙක්ට එයා first group එකේ ඉන්න නිසා එයාට එක electron එකක් අයින් කරලා noble gas වල තියෙන electronic configuration එකට කියන complete electronic configuration එකක් reach කරන්න පුළුවන්. හරිද? එතකොට sodiumටත් එහෙමයි, potassiumටත් එහෙමයි, because they have to go far forward in order to reach this one. කියන්නේ එයාගේම පීරියඩ් එකේ ඉන්න නෝබල් ගෑස් එක රීච් කරනොත් එයාට ඉලෙක්ට්‍රෝන තව 7ක් විතර ගන්න වෙනවා. ලිතියම්ටත් එහෙම. හැබැයි ඊට ඔක්කොටම වඩා ලේසි ඒගලන්ට තියෙන ඒවා give up කරලා දැම්මහම අර ආපස්සට තියෙන නෝබල් ගෑස් එකේ ඉලෙක්ට්‍රොනික කන්ෆිගරේෂන් එක ගන්න පුළුවන්. Got that point? Okay. එතකොට what is their chemical properties? Metals form positive ions. If when they remove their electrons, they get positive ions, as same as we tell them as cations. Positive ions කියනවා, cations කියනවා. By what? Losing electrons. They combine with oxygen and form what? Which kind of oxides? Basic oxides. The oxides, when dissolved in water, form basic solutions. So they are the chemical 3 properties of metals. And we are going to discuss, as previously I mentioned, we are going to discuss some metallic elements. Here we have sodium. Sodium is a metallic element belonging to group 1 of the periodic table. It is a highly reactive element. It never exists as a native metal. Due to their high reactivity, they can't stay in nature as native metal. Silver and gold, they have relatively low reactivity. That's why they can stay in the environment as native metal. But sodium, it is very reactive, so it's going to react with air, water and everything, so it can't be kept as a native metal. Okay, so that's why because of its its high reactivity, it exists only as how? Compound. Okay, sodium chloride is the main compound containing sodium, and it occurs in seawater. So NaCl, sodium chloride, is the main compound of sodium. Now, sodium metal is stored in paraffin oil or kerosene, so that it does not come into contact with air. When sodium metal is taken out of paraffin oil, its luster disappears with time. Why? Because it reacts with air very quickly. Uh, the metal can easily be cut with a knife. The freshly cut surface offers a silvery luster, but it gets tarnished after some time. Okay. Now we are going to learn about physical properties of sodium metal as previously uh, told by what you may remember that as the general properties of common properties of metals, they have mentioned their density is somewhat high, but in here sodium floats on water because its density is less than that of water. So this is a special scenario, less than that of water, and it's a conductor of heat and electricity, as we already know. And this is a soft metal, soft metal, which can easily be cut with a knife. Okay. Then chemical properties of sodium metal. Sodium shows a high reactivity towards oxygen. It reacts how? It reacts rapidly with oxygen in air to form the metal. Oxide of the metal, okay. And sodium metal vigorously react with whom? Vigorously. Sodium metal vigorously reacts with cold water, forming sodium hydroxide and hydrogen gas. So with oxygen it reacts rapidly, and when it comes to cold water it vigorously reacts. And what about hot water, not hot water, dilute acids, it reacts violently, so they ask you to do not attempt this. Since this is extremely dangerous, you shouldn't attempt this with dilute sulfuric or dilute HCl acid. This react violently. Violently means more than vigorously, more than rapidly. Okay. So when it comes to uses, production of sodium cyanide using the extraction of gold and silver. Using the extraction of, in order to extract the gold and silver, you could use sodium cyanide. Making sodium amalgam, which is used as a reducing agent in organic chemistry. Extraction of metals such as titanium, zirconium form their compounds. Production of indigo dye used into dye trouser material. Denim. Used in the production of street lamps without a yellow glow. Okay, just go through them. I'll give you 20 seconds. Okay, then we come to magnesium. Magnesium is a metal. Light reactive metal. It does not exist as a native metal in the nature. In seawater, it occurs as what? As same as the sodium chloride. This also exists as magnesium chloride in seawater. When exposed to air, magnesium tarnish, so luster cannot be seen. But when cleaned with the sandpaper, the luster becomes visible. Uh, Physical properties, it is a good conductor of heat and electricity. Higher density, okay, here we come to magnesium. It has higher density than that of water. In previous case, when it was sodium, it has a low density than water. Okay, so it float. But here magnesium has high density for than that of water. And when we come to chemical properties of magnesium, when heated in air, magnesium burns with bright white flame, giving white magnesium oxide. So I don't know whether what we have to do it with yeah as a use. Oh, no, it's a chemical property, no? So when heated in air, magnesium burns with bright white flame and give the white magnesium oxide powder. And magnesium does not react with cold water but react with hot water. So it does not react with cold water, see. But and also in the air we have to burn it by giving oxygen. That's why we get magnesium oxide. But when it comes to sodium, it just react with air at very first place when it contacted with air. Okay, so here this has to burn on air and get a bright white flame, and also magnesium oxide white powder. Magnesium does not react with cold water but react with hot water. That means you remember when sodium react very vigorously with cold water, but magnesium does not react with cold water and it reacts with hot water. As a result, it forms magnesium hydroxide and hydrogen gas. When the metal is strongly heated in steam, magnesium oxide and hydrogen gas are formed. Okay. As a result, it forms magnesium hydroxide as a sodium thing, and a hydrogen gas. When a metal is strongly heated in steam, magnesium oxide and hydrogen gas are formed. Magnesium rapidly reacts with dilute acid and forms a corresponding magnesium salt and hydrogen gas. Uses of magnesium. By mixing magnesium with aluminium, an alloy called magnesium is uh, produced. This alloy is strong and resistant to corrosion. It is used in aircraft industry and in making parts of automobiles. Production of medicines as milk of magnesia and use of metal that prevent corrosion of iron. Use as a metal to prevent corrosion of iron, and production of medicines mixing magnesium with aluminium and alloy called magnesium is produced. So for the magnesium, this alloy is strong and resistant to corrosion. It is used in aircraft industry and not uh, mainly for the home things. Okay. Okay. Then we have discussed about nonmetals. General nonmetals have properties opposite to those of metals. There are nonmetals which occur as native elements as well as compounds. So it has both native elements and also compounds of other elements. Some nonmetals occur in solid state while some exist in liquid state. So this has multiple characteristics. And gaseous states. At room temperature, carbon, sulfur, phosphorus and iodine exist in the solid. So they have given examples. But carbon, sulfur and phosphorus have given, let's highlight it. Oh no. Carbon, sulfur, phosphorus and iodine exist as in the solid. Bromine is a liquid. Bromine. Yeah, I'm going to highlight the solid nonmetals from carbon to iodine. So bromine is a liquid. So bromine, when it comes to bromine is a liquid at room temperature. Chlorine, fluorine, nitrogen and oxygen are some metals occurring in which state? They are in gaseous. Chlorine, fluorine, nitrogen and oxygen are some nonmetals occurring in the gaseous state. So you could find some as carbon, sulfur, phosphorus, iodine, they stay in the solid state, bromine in liquid, and chlorine, fluorine, nitrogen, oxygen in the gaseous state. So when it comes to nonmetals, there are different uh, elements which are in different states. Nonmetals do not have a metallic luster, so it does not have a metallic luster. They cannot be hammered into sheets or drawn into what? Here. It does not have metallic luster. Highlight the things which I do, okay? They cannot be hammered into sheet or drawn into wires. Cannot hammered. Many nonmetals are brittle and poor conductors of heat and electricity. However, graphite, a nonmetal, is a conductor of electricity, so this is an exception. And however, graphite, a nonmetal, is a conductor of electricity. So this is another exception, conductor of electricity. Nonmetals have a relatively low density, but the density of diamond is high. Nonmetals have a relatively low density, but when it comes to diamond, its density, it's an exception, its density is high. So chemical properties of nonmetals form negative ions, that means anions. Many oxides formed by nonmetals with oxygen are acidic. Mostly these exist in the gaseous state. They easily dissolve in water and form acids. Here some non-metal elements, under that it's nitrogen, sulfur, yeah. So we have to discuss these parts, and I'm going to stop here for right now, and I'll discuss the other part later. Thank you.